Okay, friends, so that was fun. We got to create our first spreadsheet. Hopefully it wasn't too traumatizing for you. We'll do more as we go through the course. But what I want to do now is share with you a tool I've built for us to do problems like the one we're doing right now. And I think you're going to see, hopefully, how it's actually more helpful than creating a spreadsheet like we just did. For example, we ended that last video by saying the incandescence cost is growing faster than the other ones. But at the time we stopped, 206 hours, whatever that is, we could not see a benefit in buying a CFL or an LED. Well, let's look at a tool that helps us see the benefit. So let's go to the Excel calculator. This is the same Excel calculator we looked at for grade. Let's crack that open. All right. The first tab that opens up is the grade tab. That's what we looked at last time. I'm going to hit enable content like we did last time. And grade was great, but we're going to click over to the next tab, which is linear modeling. And you might think to yourself, like, how is this related to grade? And don't worry, it is, but it might not seem it right now, and don't worry about it right now. When you come over here, you see a little spreadsheet that I've already kind of started for you. And what we're going to do is we're going to fill it in as we go. Part of this class is learning how to think statistically and look at data statistically. And that's what this helps us begin to do. It helps us take the stuff we did in the last spreadsheet, the idea of the equation of total cost, and then it allows us to put it together in a visual way. So it takes care of the math for us in the background and lets us just visualize what's happening with the costs. Okay, so we're going to be making a plot of the data we looked at in that spreadsheet. So the first thing I'm going to do is give this plot a title. Let's see. We're looking at the total, whoops, hit the wrong button. Apologies. Click in there. Total cost of incandescent CFL and LED light bulbs. There we go. And when you type the title there, it shows up over here in the chart. I've set that up there. And I'm going to show you how to build stuff like this later in the course, but for right now, we've got it done for you. Okay, so that's step one. Step two, run and rise. So the run is the horizontal and the rise is the vertical. You're now seeing how this ties back to grade. So the run, if you think about it and think about old math classes you've taken, this is your independent variable. This is what's being allowed to vary. And the rise is dependent on the run. So if you think about what we made our independent variable be in the last couple of videos, it was hours burned. Hours that the bulbs were burned. So each hour goes up by 1. And you can see already that I've got this one set to go out to 200 hours, which is just about as far as we took that spreadsheet in the last video. The rise is going to be the total cost, because that's what we're actually interested in, is we're interested in the cost of these bulbs over a period of time. Okay. Now, this next bit is the part that actually sets up the visual for us. I've given us 3 different lines, or the capacity to look at 3 different lines. So I'm going to type over line 1, I'm going to type INC for incandescent, and then CFL for compact fluorescent, and then LED for light emitting diode. Okay, and you'll notice as you do that, that over here, those update incandescent CFL LED. And what you're going to see is you're going to see 3 different lines show up as you as we start filling in this little chart right here. All right, incandescent. Now, I've given you variable cost and fixed cost. So variable cost for an incandescent, if you remember, was $0.006 per hour. If I press enter right there, you see that there's a line. It just popped up. Now, we're not done yet because the fixed cost is also $0.5 or 50 cents. And all that did was it shifted it up. So this blue line right here represents the set of all points, including the ones we created in the last spreadsheet, but also all the points in between, like the half hours and the 1.5 hours and the 7.2 hours. It's a continuum of all those costs, starting at 50 cents and moving out till it's about, looks like it's about $1.70 here at the end, ish. And we'll, again, a lot of this is going to be ish. In the optional video at the end of today's playlist, we'll do the algebra. If some of you like algebra, and we can look at the algebraic solutions that we're about to look visually. But this is a very graphical, very statistical, very approximate, very making sure this makes sense look at the data. Okay, CFL, variable cost, is 0.0014, and the fixed cost is 3. Now, you might notice a couple things. First of all, the CFL's cost is way up here compared to the incandescents, but we knew that based on what we looked at last time, because we knew even after 200 or so hours, the total cost was still less than the starting cost back here for the CFL, and that's just because the CFL costs so much more. All right, and the LED was 0.001 per hour with a fixed cost of $5. All right, so these lines essentially represent the same data we looked at in our spreadsheet before, okay? So if you're only going to burn a bulb for 200 hours before you're done using that bulb, then there's absolutely no reason to purchase an LED or a CFL because an incandescent is cheaper overall. But 200 hours might not be a long enough time to discuss. We think about 200 hours. 200 hours, actually, let's make it a little bit easier. Let's make it 240 hours. Okay? That would be 10 days running the bulbs around the clock. Now, nobody actually, well, I don't know. We've got a 12-year-old in the house. Sometimes we do have lights on that are running around the clock, but most people don't have light bulbs running for 24 hours. So if this were 10 days running 24 hours a day, that's the same as 20 days running 12 hours a day, or 40 days running 6 hours a day, or however you want to break it down. But still, after 240 hours, it still doesn't make any sense to buy anything other than an incandescent. How about 300 hours? Still doesn't make any sense, but hopefully you're noticing something. This blue line is tilted upward more than this red line is. That means it's going to intersect it at some point. What I'd love for you to do right now is just hit pause, mess with this value in run max, and try to get the blue line to hit the red line. Go ahead and hit pause and try. All right, let's see if I can do it. Let's go out 500 hours. 500 hours. Oh, so close. 600 hours. All right, we got it. We got it. There it is right there. Now, what does that intersection mean? Well, if we look at that as a point, if we drop that down, it's roughly at 550 hours, just about at 550 hours. At 550 hours, both the CFL and the incandescent bulbs cost the same amount. Before 550 hours, the incandescent bulb was cheaper than the CFL. And after 550 hours, the CFL is cheaper than the incandescent. But at about 550 hours or so, and again, this is all approximate. I'm not looking for perfect numbers here. I'm looking for approximate numbers. At about 550 hours, they cost the same. We call that a break-even point. That's when the two bulbs costs break even. And what economists and business folks use is they use that to make decisions. If the bulb, for example, if we're going to use it for less than 550 hours, then buy an incandescent. If you're going to use it for more than 550 hours, then buy a CFL. All right. Now you might notice something else. You might also notice that the incandescent is eventually going to catch the LED, which again makes perfect sense because it's tilted more. Give it a shot. See if you can figure out when it is. Hit pause and try to find it. All right, let's figure it out. Let's go out 1,000 hours. We got it. We got it. Okay, so I went 1,000. Just so you know, when you change your run max value, what that's actually changing is the maximum value of 1,000. I forget why I set this to go further, but it doesn't matter. You can ignore all this blank space. This 1,000 right here is the maximum value. The actual intersection, though, happens back here If I drop that, it's about 900, maybe a little bit more. So that little intersection right there is right about at 900 hours. So once you hit 900 hours, the incandescent costs the same as the LED. Anything past that, the incandescent costs more. So we knew this was going to happen. We knew it was going to happen because the incandescent has a greater slope. So it has to intersect the other two at some point. All right, one last thing to think about before we move past this. Will the CFL line ever intersect the LED line? Think about that. It has to, because the CFL has a greater slope than the LED. It's hard to see. It's hard to see on this graph right here. But that line is tilted upward a little bit more than that line is. And since this line is tilted up more than that line, that means eventually this thing is going to rise up and catch it. All right, so we know a couple things. We know it's going to hit it. We know it's going to hit it out here somewhere. So I think hit pause and try to figure out what that run max needs to be to see it. Go for it. Okay, here we go. Let's change it to 2,000. 2,000 hours. Not quite 2,000. Let's try 3,000. Oh, we're getting there. I want to jump to 5,000 because I'm getting impatient. Oh, we may have found it. You know what is causing grief, though? This incandescent line is kind of a pain in the butt. I'm going to delete the values for the incandescent over here, and that way it'll, there we go. It's a little bit easier to see. It's hard to see with that incandescent bulb kind of screwing the graph up. Oh, it looks like they may have hit, but I'm going to go, you know what? I'm going to go past it. I'm going to go to 7,500, just so I can actually see. Yeah, there's a very clear look at where they cross. Okay, so right at about 5,000 hours. It takes about 5,000 hours until the LED becomes cheaper than the CFL. At that point, that's your break even for the incandescent and the, for the CFL and the LED. And you can put, what's kind of fun is you can actually put the incandescent back in there just to see look at how far back. You can see now why LED bulbs are being marketed so well, because they tend to last a nice long time. And they use so much less energy. As a matter of fact, I just said one thing incorrectly there. They use so much less energy than the other two. So at this point, you might be thinking to yourself, wow, 5,000 hours isn't that long. And we're going to talk more about that in your quizzes, both during and also for Friday. Is there any downside to LEDs? They definitely are cheaper to run over longer periods of time. But are there any downsides? So as a real quick finale to this, we're going to look at some of the downsides. There's not many, but there are a few downsides to consider about these bulbs. One is their lifespans. And I did a little bit of Googling, and I've looked at the incandescents actually don't last as long as CFLs, and CFLs don't last as long on average. This is all on average as LEDs. Since an incandescent bulb is actually a filament heating up, it tends to break down quicker than the other ones. It's actually more of a mechanical kind of process. So the idea is LED bulbs look even better because the lifespan is so much greater. I'm going to have a Friday quiz for you all to actually analyze how to adjust for these 1,200 hours for the incandescent and the 8,000 for the CFL. But it's not all positive for LEDs and CFLs, okay? There's a couple things you have to think about. I've given you some chemical elements here, and those of you that have taken chemistry classes might recognize these as mercury, lead, nickel, and copper. Mercury, unfortunately, is an element in CFL bulbs, and lead, nickel, and copper are all in LED bulbs. What that means is the when these bulbs do die, when they burn out, so to speak, you can't just chuck them in the trash. These are hazardous wastes. You can't just throw them in the garbage and have them go to the landfill. Well, I shouldn't say that. You can do that. You shouldn't do that. You should recycle them. An incandescent bulb has nothing toxic in it. It's got glass, some metal, and that's about it. mercury in CFLs should not go in the ground, and lead, nickel, and copper should also not go in the ground. This thing actually has a circuit board. If you take one of these apart, please don't, but if you take one of these apart, there's actually a circuit board on board inside of it. As a matter of fact, this is an interesting little side note. On the resources page for our course, under linear modeling, a former student of mine actually decided to break down the analysis of CFLs and LEDs and figure out just how toxic they are. So if anybody wants to get lost and geek out with some chemistry, some dimensional analysis, and a really, really well-written paper on how toxic CFL and LED bulbs are, this is a great little resource for you. Just heads up, they're not super toxic right off the bat. Well, anyway, I'm not going to say any more than that because you've got enough on your plate besides reading that paper. So anyway, the moral of this story is don't throw these things in the trash. If you have a hard time recycling them, bring them to my office at Grandview. I'll recycle them for you. And the last thing is price over time. Everything gets cheaper as the technology gets more available. And LEDs are no exception. I told you that an LED bulb, my first LED bulb I ever bought, was $21 or $26, excuse me, and now they're down to much, much less than that, a fraction of that, which again makes LEDs look even better. So looking at all the positives and the negatives, even with the chemical negatives of LEDs, they are becoming more and more popular for good reasons. As a matter of fact, this is a wonderful little chart the New York Times put out a couple years ago that shows the percentage of bulbs in homes in U.S. from 2010 through 2016, and you're beginning to see that traditional incandescent bulbs are beginning to be used less and less, from 2/3 down to about 1 in 16. And compact fluorescents have increased a little bit, but LEDs are the big star. There are almost no homes in 2010 with LEDs, mostly because you couldn't get them. And now 1 in 7 homes have them, which is pretty cool. Or 1 in 7 bulbs in America are LED bulbs. For your assignment after these videos, I didn't bring in halogen incandescent intentionally. We're going to bring that one in as a follow-up for the for your assignment to do after this series of videos. So let's try that now. Now, for those of you who want to look at this algebraically, I'm going to have an optional video after this one that walks through the algebra for this. So if you want to skip all this Excel stuff that we just did, all this, you don't like any of this stuff, I think this is great because it shows us a nice visual. You don't have to. If you want to just do algebra, I'm going to have an optional video after this one, and we'll walk you through some of the algebra. Okay, so if you want to just use the tools we've learned today and attack the assignment for today, go for it. And if you don't, hang tight. Next video, we'll do some algebra.